Hello, this is Mr. Hendrickson. In this video, I am going to work through the multiple choice section of the August 2024 Regents exam. But I'm going to do this multiple choice only using information that we've learned in the IM Units 1, 2, 3, and the beginning of Unit 4. So that is one variable statistics, linear equations and inequalities and systems, two variable statistics, and the beginning of functions. So for questions that fall in those units, I will do them using the information we know. But for questions that fall outside of them, I'm going to show you how you can approach those questions using just the information that you already know to make an educated guess or to even figure out the final answer. Before I do any of the questions, what I'm going to do is I'm going to work through the entire thing and I'm going to rank every question as either a 1. A 1 means we know how to do this. A 2, questions that are level 2 mean we know some of this, but there are some unfamiliar equations or vocab. And category 3 would be questions where we know very little. So we might need to make an educated guess. So I'm going to work through just the multiple choice, rank every question, and then I'm going to go back through and solve them in order. So first, the first question asks me, what is the correct factorization of x squared plus 4x minus 12? And then they give me 4 options. I am going to rank this category 2 because I don't know what the word factorization means, but I do see an expression and then I see some other expressions, so I might be able to just use what I know about equivalence to make a strong guess. Second question, which situation can be modeled by a linear function? I'm also going to call this a category 2. I've studied linear functions, but we have not yet studied other types of functions as much, so it might be difficult to recognize what is and is not a linear function. Third one, which expression is equivalent to 3x squared minus 2x plus 3 minus 4x squared plus 3x minus 1. Even though this falls in a later unit, I'm going to call this category 1. We know what equivalence is, and so we can use our understanding of equivalence to solve that. Number 4, we have a word problem. I'm not going to read the entire thing right now, but we have a word problem, and it looks like we are modeling this word problem with an equation. We did that in Unit 1, so I'm going to call that category 1. Number 5, I see a few things that I do not know. So I have not seen this phrasing fourth degree trinomial, but I have seen the words coefficient and I have seen the words constant. So I'm going to rate this a 2. I think I can make an educated guess. Number 6, I see different properties. So this seems like an acceptable moves question. I may be a little unfamiliar with some of the language, but I feel confident in what moves are acceptable, so I think I'll be able to figure that out. Number 7, I'm going to call number 7 a category 2 because we haven't talked about irrational numbers this year, but you may have seen them in middle school. Number 8, we have not worked with quadratic equations very much, but we do know what solutions are. So I'm going to call this category 2. You see that a lot of this is category 2. We know some of it, not all of it. Number 9, this should make me feel confident. This is from Unit 1, one variable statistics, box plots. Number 10, I have a table and they're asking me for average rate of change. So average rate of change, I'm going to call that category 2 because we haven't covered it yet, but you may have seen a version of it in middle school. Number 11, we have a function equation, and they're asking me about the graph. So I know how to graph. I'm going to call that category 1. Number 12, the amount of money, I have a linear function, and they're asking me to interpret it. That sounds like Unit 2. Number 13, that's Unit 2. Number 14, we love a good two-way table. That's Unit 3. Number 15, we have not dealt with radicals yet, but I do know what a sum is. So I'm going to call that category 2. Here I have two functions. They're asking me about when they're graphed, what the solutions are. I have not graphed x squared, but I know what solutions are. I know how to graph. I'm going to call that category 1. 17, this looks scary. I have polynomial, but I know what the word product is. So even though I don't know what a polynomial is yet, I know what product is. I know what equivalent is. I'm going to call that a category 2. Number 18, we have a line. We want to know if it's going through a point and a slope. I know all those things, category 1. Geometric sequence. I'm going to call this a category 3, but I do have an extension packet of this, so if you're curious about it, I can show you. Number 20 is difficult, but we did it in Unit 2. 21, I don't know what a 0 is, but I see a lot of different functions, so I could at least graph them and then guess. I'm going to call that a 2. Number 22, I have not dealt with exponent this much, but I do know what equivalent is, so I'm going to just call that a category 2. And then number 23, we have another sequence. I'm going to call that a category 3. I don't know what this vocab means. And number 24, I'm going to call this category 2 because you may be able to figure it out based on what you know from middle school. So in total, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 questions in category 2. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 questions where we feel like we know what all of the terms mean in category 1. And we only have 2 questions where we know very little. So looking at our multiple choice section, even though we have only completely learned 11 of the questions, you should feel confident at least doing process of elimination and educated guessing on almost the entire section based on what we already know. So now what I'm going to do is I'm going to go in order and just use skills from units 1 through 4 to explain each of these. So first, we have a category 2 question. What is the correct factorization of x squared plus 4x minus 12? I do not know what factorization is, but I do notice that I have an expression, x squared plus 4x minus 12, and all of my answer choices are other expressions. So anytime I have an expression and I'm looking for other expressions, I'm going to assume that they want me to say which one is equivalent. Maybe I'm wrong, but based on what I know, that seems like a good assumption. So what I'm going to do is I'm going to put my question into y1 on my graphing calculator. So if I put this in y1, what I'm going to do is one at a time, put my answers into y2 and compare the tables. So in y1, I have x squared plus 4x minus 12. And the first one, I'm just going to check out answer choice A to begin, answer choice 1 to begin. And I'm going to type parentheses x plus 3, parentheses x minus 4 into y2. When I type this in, if I go to my table, what I see is that y1 and y2 do not match. So even though I don't know what factorization is, answer 1 is not matching the question. I'm going to try again with answer 2. Answer 2 says x minus 3 parentheses, x plus 4 in parentheses. So if I type this into y2, and go to my table, once again they do not match. Now I'm going to take a look at answer choice 3, x plus 2 in y2, x minus 6. When I look at my table, that one still does not match. So I'm hoping that answer choice 4 matches, because if answer choice 4 matches, then I can be pretty confident that I know what's up. So now in y2, I'm going to type answer choice 4, x minus 2, x plus 6. Go back to my table. And now in my table, I see what I know equivalence means. I have my x column, I have my y1 column, I have my y2 column, and on my screen right now I'm looking at -2 through +2, and for every single row, my values are matching up between y1 and y2. So I have found something that matches. So even though I don't know what factorization means, just based on knowing what equivalent means, both of these two expressions are giving me all the same y values for all the same x values. They seem to have all of the same solutions if I set them equal to y. So I can feel pretty confident that answer choice 4 is my answer. Moving on to 2, which situation can be modeled by a linear function? Before I look at my answer choices, I'm just going to write down what I do know about linear functions. So linear functions, I know if I graph this, it's going to be a straight line, because everything we did in Unit 2 was a straight line. I also know that they, in their equations, have things like 4x plus 3 or 2x minus 1. So this has a constant slope. So I'm going to read through my answer choices and see what I think. First, I have a printer can print 1 page every 3 seconds. So 1 page every 3 seconds, this sounds like a rate. It sounds like this rate does not change. Number 2, I have a bank account earns 0.5% interest each year. 0.5% interest, that also sounds pretty consistent, but I see some words that I have not studied yet. And I know I studied linear functions in Unit 2, and I have not heard the words compounded annually. I know we have not studied interest. So I'm going to put some question marks here. That sounds like maybe it's from a future unit. Number 3, the number of cells in an organism doubles every 4 days. This one sounds tempting, but if I think of doubling, I think of something like if I start with 1, then I have 2, then I have 4, then I have 8, then I have 16, and that's kind of looking like one of those functions we did in the last week of school that was not a straight line. So the doubling is making me a little hesitant. And then number 4, attendance at a professional sports team's game decreases by 1.5% each year. So here's another extra hint just in terms of problem solving. I know I only have one answer choice, but I have 2 options that are both percent change each year. So if we're looking for what's different, I'm pretty sure it can't be 2 or 4 because both of those have percent change every year. And we know we only have one correct answer. So I'm going to get rid of 2 and 4. And then between 1 and 3, they are both tempting. But if I think of unit 2, a printer can print 1 page every 3 seconds. I could model that as y equals 3x. If x is seconds and y is pages. Right? After 0 seconds, there are 0 pages. After 10 seconds, there are 30 pages. So I'm pretty sure something like number 1 could have shown up in our unit on linear functions. I'm going to choose answer choice number 1. Number 3, which expression is equivalent to 3 parentheses x squared minus 2x plus 3 minus parentheses 4x squared plus 3x minus 1? This one I'm going to use the same exact strategy as I did in number 1. If I see this word equivalent, I immediately want to think equivalent expressions have all of the same solutions, or equivalent equations have all of the same solutions. So I am going to put my question in y1. And for this one, it'll be a little time consuming. This is a lot of typing, but if I'm careful, the typing will be worth it. So I'll go to my calculator, put all this stuff in y1. I'm going to trust that I'm going to learn why it's equivalent later in the year. But for now, I know what equivalent means, and that's enough. In y2, I'm going to put my answer choices one at a time and see which one matches in the table. So for this one, I'll let you pause the video and try typing it in to figure out which one has matching tables when you type them all in. But the correct answer is going to be, after you do the equivalent trick, the correct answer should be number 4. So if you put negative x squared minus 9x plus 10 into y2, you will see in your table that these are equivalent because they have all of the same solutions everywhere in the table. Moving on to number 4, now we have a long word problem. So I have all this information. I immediately, before I want to dive in, I'm just going to set up my knowns and my unknowns right away. I don't want to leave all of this information in their wording. I want to put it in my own wording. At Adeline's first birthday party, each guest brought $1 in coins for her piggy bank. Okay, so $1 in coins per guest. Guests brought nickels, dimes, and quarters for a total of $28. So we have $28 total. And we have nickels, which I'm just going to remind myself right away. A nickel is 5 cents. We have dimes for 10 cents. And we have quarters for 25 cents. So these things are combining to create $28 total. There were twice as many dimes as nickels. Okay, so now I have a relationship. So dimes is double nickels. I have twice as many dimes as nickels. and there were 12 more quarters than nickels. So more than sounds like addition. So quarters equals nickels plus 12. Which equation could be used to determine the number of nickels, x? Okay, they're defining a variable for me, so they're saying x is nickels, that her guests brought to her party. Okay, so I have a lot of pieces here, and I have a lot of variables, but what I'm noticing looking at their equations is all of their equations only have x. So I'm going to start by writing my own equation that's a little simpler. I know that 0.5 of nickels, which was x, plus 10 cents for every dime, plus 25 cents for every quarter, equals $28. Right? So I know I have the basic structure, which kind of looks like number one. However, in number one, they're using x for everything. So what I need to figure out is looking at my other answer choices, which one is defining dimes correctly and which one's defining quarters correctly. So I'm just going to focus on dimes first. I know that dimes was double nickels. So if I look through here, I see double nickels and I see double nickels. So this seems like it's correct, even though I didn't have to write it myself. And then I also want quarters. I want quarters to be represented as 12 more than nickels. So quarters are going to be x plus 12, or I said n plus 12 over here. So if I look for answer choices that have quarters, I have this one, and I have this one. So now looking through places where I have stuff that's wrong, this seems wrong, this seems wrong, this seems wrong. It seems like the answer that has everything right is answer choice 2. I have 5 cents for every nickel, plus 10 cents for every dime, and I know dimes are double quarters, plus 25 cents for every quarter, and I know I have 12 more quarters than nickels, and I have a total of $28. So in this one, I kind of melded the strategies. I started by writing my own equation, and then once I got close, then I began looking at the answer choices, looking for things that were wrong, and identifying which answer choice matched my organization of the information the best. Question 5. Here we have some things we don't know, so we just want to focus on what we know, not get distracted by what we don't. We don't know what a fourth degree trinomial is. That will be very fun when we learn it. But I do know what a constant value is. I know that a constant is something that does not change. And so it has no variable. So if I'm looking at these answer choices and I want my constant value to be 5, I'm going to notice that answer choices 1 and 3 have 5 without a variable on them. But it seems like the constant value in 2 and 4 is plus 3. So I don't need to know anything about trinomials to say it looks like the constant value of 5 is only in answer choices 1 and 3. Let's think of what else I know. I don't know what a fourth degree trinomial is, but I remember that a coefficient, I'm pretty sure a coefficient is something that's multiplied by a variable. So looking between answer choices 1 and 3, I see a coefficient of 2 versus a coefficient of 4. I'm going to guess 1 because I know it has a constant term of 5, and I think that that 2 is probably the leading coefficient. So even though I don't know what a trinomial is yet, I can feel pretty confident that answer choice 1 has a constant term of 5 and it has a coefficient of 2. Number 6, when solving the equation 4x squared minus 16 equals 0, Laura wrote 4x squared equals 16 as her first step. So first, let's just figure out how she got there. She started here, and she got to here. What I'm noticing is that the 4x squared did not move, but the 16 switched sides. So I'm just going to do on my own. It seems like she added 16 to the left side and the right side. We know this is an acceptable move because she kept her two expressions balanced. When she did this, she got 4x squared equals 16. So I know what she did is she added on both sides. So now looking at my answer choices, she did not do any distribution. So that's not the distributive property. She didn't multiply anything. So it's probably not the multiplication property. Commutative property. We talked about this in Unit 2, but I'm going to pretend I forget. I do know she did some addition, but I don't remember what commutative property meant. And then I have addition property of equality. So the way we talked about properties in Unit 2, you may be debating between questions 3 and 4. And what I'm going to say is that's okay. If you're between 3 and 4, but you know that they didn't do distribution, they didn't do multiplication, that's an okay place to be. This is the additive property of equality. If it was the commutative property of addition, that would be when you're switching the position of things that are on the same side. So the commutative property is things like A plus B is the same as B plus A, which we did not need to do here. But if you're at least guessing between answer choices 3 and 4, then you're in good shape. Number 7, which expression results in an irrational number? I put this as a category 2 because some people might remember this from middle school, but even if you have never heard the word irrational before, we have 4 numbers, and they're asking us which one is a certain type of number. And what we can do is we can type all of these in just to see which one looks different. So if I type in radical 3 times radical 3 in my calculator, and I hit enter, I get 3. If I type in 5 times radical 81 in my calculator, I get 45. If I type in negative 2/3 plus 1/4 in my calculator, and I use the alpha y equals for the fractions, then I am going to get negative 5 over 12. You may also get a decimal. So really quickly, if your calculator gives you a decimal, the decimal is negative 0.416666 ... So my calculator will either give me negative 5/12 or negative 0.41666666. And then lastly, if I type in 1/3 plus the square root of 3, I get 2.065384101409. So if they're asking me which thing results in an irrational number, what I'm going to notice is that 2 of my answer choices are whole numbers. So they seem like they're in the same category. It's probably not that one because I'm looking for what is different. Answer choices 2 and 4 are both decimals, but I'm going to notice that answer choice 2 is at least a repeating decimal. Answer choice 4 seems really weird because it's a decimal that goes on and on and on without any pattern. So you may logically guess that 4 is our irrational number because it seems like the least convenient. It's a decimal that goes on without any pattern. But for this one, what I'd encourage you may guess correctly, you may guess incorrectly. If you're given one of these questions where you just have 4 answers, a strategy you can use is which one doesn't belong. Which one of these is most different? We had 2 whole numbers, we had 1 fraction, and then we had 1 weirdo. If you can identify something that in your opinion seems like the weirdo, that's the best guess, especially if everything else seems to have something in common. If you're curious, the definition of an irrational number is a decimal that does not terminate or repeat. So if you have a decimal that goes on and on and on without any pattern, that is irrational. However, moral of the story in 7 is at least type them in, see which one seems different. Number 2, which equation has the same solutions as x squared plus 6x minus 18 equals 0? This one's going to be very difficult to use what we already know, but I would encourage you to at least think about what solutions are. So we know that solutions make an equation true. So what this question is asking us is, which of these equation has the same value of x, make it true as makes this true? The way we could kind of get a guess here, and this one is going to be very difficult, so give yourself grace if this one's a reach for you. We know a solution makes it true, so we could type this equation into y1, and then we could just try to observe on our graph what is getting this equation close to 0. So if I type this equation in, x squared plus 6x minus 18, I know I want it to equal 0, so I'm going to scroll around in my table, and what I'm going to notice is that the part of my table that gets closest to 0, there's nowhere in my table where it gives me straight up 0, but the part of my table that gets closest to 0 is, it starts at negative 18, then it goes negative 11. So here's the part of my table that it seems like it gets really close to 0, is near 2, right? 9 is far from 0, negative 11 is far from 0. So somewhere in here, a little above 2, this equation is hitting 0. I don't know how to figure out the exact value, right? Maybe we're going to learn that later in the year. But I know that the 0 is going to happen somewhere between 2 and 3. So what I'm going to do is I'm going to just plug 2 into each of my answer choices and see which answer choice seems almost true if x is 2. Because when x was 2, my original problem was almost true. So in answer choice 1, if I do 2 plus 3 squared, I get 25. That's close to 24. If I do 2 plus 3 squared, I still get 25 in answer choice 2. It seems like it's closer to answer choice 1. So I'm going to get rid of this. If I do 2 plus 6 squared, 2 plus 6 squared does not get me close to 24. 2 plus 6 squared is giving me 2 plus 6 squared is giving me 64. So I can pretty confidently get rid of these, because anything close to 2 is not making those true. These, it's kind of borderline, but I could guess number 1. Let me think really quick in my head. Is that correct? In this example, this is a good example of kind of like give yourself grace. If you use this strategy, x plus 3 squared, that gives me... If you're watching this video, be patient for 1 second. I have to think x plus 3. I'm going to write out what we're going to learn. X plus 3 squared plus 6x plus 9 minus 27. Yeah. So in this question, the correct answer was actually number 2. And so sometimes if you're doing things that are in this second category, if you know the word solution, but you don't know everything that's going on, you get yourself close. 3 and 4 were both wrong. 1 seemed like the most tempting answer. But in this case, without knowing what we know from the future, we would have gotten this question wrong, and that's okay. We don't need every single thing right. But I do want you, anytime you see the word solution, I want you at least trying to figure out what are numbers that almost work here, and can I find a number that kind of makes both of them work? Don't do these questions first, but try to muscle your way through them, because if you think of our number 2s so far, we've done 1, 2, 3, 4, 5. We've done 5 of them, and this is the first time where kind of like just using what we do know wasn't enough. Okay? But 8 is very fun. We'll do it in Unit 6 and 7. Number 1, now we're back home. Good old box plot. So we have the height in inches of 8 football players are given below. If you are asked to do a box plot, if you like doing these by hand, that's wonderful, but I always want you to check it in your calculator just in case, because there may be some type of weird rule about whether you're excluding the minimum or whatever. So as a reminder, to create a box plot, you're going to go to Stat, Edit, and you are going to type your answers, not your answers, you're going to type your data into L1. So if I type this data into L1, I have 76, 70, 72, 70 again. Make sure you type both 70s, not just one of them. 69, 71, 78, 74. And then I'm going to double check. There are 8 numbers on the problem. I have 8 values in my table. And I'm going to reread that I typed them in exactly correctly. If I mess up even one of them, it's going to mess up the whole thing. So I've typed them into L1. And now to find my 5-number summary, I'm going to click Stat again, Calc, and I'm going to do one variable, Stats. So Stat, Calc, one variable, Stats. And then that will bring me to a screen that gives me a variety of things. If I scroll down to the bottom of that screen, it gives me my 5-number summary. And my 5-number summary tells me my minimum is 69. My Q1 is 70. My median is 71.5. Q3 is 75. And my max is 78. So now I have my 5-number summary. I just need to compare each of my box plots and use process of elimination to figure out which one is incorrect. So I'm going to start just with the minimum. If my minimum should be 69, I can get rid of this answer choice because I see my minimum's at 65. So I can get rid of options 1 and 2 just based off the minimum. And then before I keep going, I'm going to compare what I have left. The only thing that seems different between options 3 and 4 is the median. So it seems like in option 4, the median is between 72 and 73. In option 1, the median is between 71 and 72. So my median is 71.5, which matches this graph. So I'm going to get rid of option 4 and choose option 3. And then really quickly, I'm just going to check that the rest matches. Q1 is 70, Q3 is 75. Maximum is 78. Minimum is 69. Option 3 looks great. Number 10, a bookstore owner recorded a number of books sold and the profit made selling the books. This is not something we will cover until after the Regents' average rate of change. However, I'd encourage you to at least try it because on the reference sheet at the back of the Regents, you do have this formula, which you might remember from middle school. Average rate of change, just think slope. So they give you this formula on the reference sheet. And they asked between, what is the rate of change between 100 and 350? So that means I'm just going to look at this part of my table. I'm going from 100 to 350. And I'm going to plug my values into this formula. So here's my y, here's my x. Here's my y2, y1. Here's my x1, here's my x2. If I substitute them in and pretend that I'm doing a slope problem, I get 425 minus 50, all divided by 350 minus 100. So my slope between those 2 points would be 375, all divided by 250. And then if I do that division, I get 1.5. So my average rate of change would be 1.5. So again, you may get an average rate of change problem that has some other confusing things going on. But if the story is straightforward, if you see average rate of change, just think slope, look for your slope formula, and pretend you're doing slope like you used to in middle school. 99% of the time, that will get you in the right direction, and you'll be okay. Number 11, if f of x equals x squared, which function represents a shift of the graph, f of x, 4 units to the right and 3 units down? So I don't know what this shift of a graph stuff is talking about, but I do know how to graph. I have an equation, and then I have some other graphs. So what I'm going to do is I'm going to just graph the starting equation. And then I'm going to put my other graphs in my calculator and see which one looks like it's going 4 to the right and 3 down. So if I graph f of x in my calculator and look at the graph, I see that the general shape is like this. So this is because I put y1 equals x squared, and then I just looked at the general shape of the graph. I don't need exact points, I just need general shape. Now what I'm going to do is I'm going to put my other graphs in and see which ones looks like it's moving 4 to the right and 3 down. So my hope is that I get something that's 4 to the right and 3 down. So start with g of x. If I type g of x into y2, then I type g of x into y2, I go back to my graph screen, and I see that g of x is up here. That seems like the opposite of where I wanted to move. So I'm going to eliminate that. Now let's try j of x. X plus 4 minus 3. Type that into y2, go back, and I see that it's like down here. So that's also not where I wanted to go. I want to go to the right, and it keeps sending it to the left. So now I'm going to try number 3, h of x. X minus 4 squared minus 3. When I type that in, I see that h of x is over here. So it looks like h of x moved to the right, and then it moved down. So I'm going to tentatively say yes to this. And I'm just going to double check that number 4 is no good. So if I type in number 4, h of x equals x minus 4 squared plus 3. Number 4 is up here, which is not where I want it to be. So this one's just asking how a graph moved. I don't have to do any fancy math. I can just make the graph, look in my calculator, and observe which one went to the right, which one went down. Answer choice 3 is the one that did that. so I can pretty confident and move on with my life. Number 12, the amount of money a plumber charges is represented by the function P of H equals 45 plus 90H. The best interpretation of the y-intercept of this function is that the plumber charges blank. So first, I'm going to double check what the y-intercept is. I know that the y-intercept is my starting point. Something I noticed that's a little strange about this function is that they put the variable at the end instead of putting it in y equals mx plus b form. So I'm going to put it in the form I'm used to. I'm just going to use the commutative property and say, what if this is 90h plus 45? If that's true, I know this is my y-intercept, right? The y-intercept is the value that does not have the variable on it. When h is 0, I'm going to be at 45. If I wasn't sure, I could type that in, go to my table, and see where does this start. When x is 0, where does this start? So my y-intercept is 45. Pretty confident that it's going to be either an answer choice 1 or 2. So now, if this is a plumber, and they're charging money, a y-intercept is a starting amount. So what I'm seeing here, $45 per hour, this is a rate, versus $45 to come to the house. That sounds more like a starting fee. So $45 per hour would be a rate. We don't want a rate, we want a starting amount. So my answer choice is answer number 1. 13, we love solving inequalities. It's our favorite. So what I'm going to do is I'm going to solve this by hand to remind you, but then I'm also going to show you how you could check your solution in the calculator. So I'm beginning with 2m minus 4 is less than or equal to 3, parentheses 2m plus 4. First thing I'm going to do is I'm going to distribute. I know that's an acceptable move. So I get 2m minus 4 is less than or equal to 6m plus 12. And then my next goal is I want all of the m's on one side and all of the numbers on the other side, all the constants on the other side. So I'm going to subtract 2m on the left and the right. So that I can get all of my m's together. So 6m minus 2m, that gives me 4m. I'm going to bring down everything else. And now I want, if my m's are on the right, I want my constants on the left. So I'm going to subtract 12 on both sides. Now I have negative 16. Nope. Yes, negative 16 is less than or equal to 4m. And then finally, to get m alone, I'm going to divide both sides by 4. In this case, I'm dividing by a positive number, so I do not need to flip my sign. I end up with negative 4 is less than or equal to m. But I noticed that they wrote everything with the m in front. So if negative 4 is less than or equal to m, that's the same as m is greater than or equal to negative 4. However, even though I'm pretty confident because I got negative 4, the answer has negative 4, I always want to be really careful about the direction of my sign. So the way I'm going to check this is I want to choose a value that is greater than negative 4 and make sure it makes the inequality true. So if I think of my number line, negative 4 is here. A value that's greater than negative 4 is negative 3. So if negative 3 works, then I'm pretty confident I'm in good shape. So I'm going to take my original equation, and I'm going to substitute in negative 3 and see if it makes things true. So on the left side, if I have 2 times negative 3 minus 4, I'm going to type all that in because I don't trust myself with the negatives. I get negative 10. On the right side, 3 times 2 times negative 3 plus 4 gives me negative 6. Negative 10 is less than negative 6. Again, if I draw myself a number line, that is true. Negative 10 is farther into debt than negative 6 is. So when I tested a point, number 4 was still true. And now I'm going to show you one third way you can think of this. I know I'm showing you a lot of ways for this problem, but this is a tricky problem. However, it's one that we have studied, so you want to aim to get it correct. If you have to do it 3 ways, that's fine. The last way I'm going to do this is I'm going to use my table to compare the left side and the right side of this inequality. I know my goal is to make the left expression less than the right expression. I want the left expression to be less than the right expression. So what I'm going to do is I'm going to type the left expression into y1. I'm going to type the right expression into y2. So in my calculator, I have y1 equals 2m minus 4. y2 equals 3 times 2. And actually, when I type these in, I have to make the m's into x's. So y equals 2x minus 4. And y2 equals 3 times 2x plus 4. Right? So I have the two things that I'm comparing. And I know my goal is y1 should be less than y2. Right? I want y1 to be less than y2. What I'm looking for is when does that happen? When is y1 less than y2? So if I go to my table and I scroll around, I'm going to look for these boundaries that are in the answer choices. And I'm just going to kind of like get to that portion of my table. So if I scroll around and I find those x values, negative 2, negative 4. Let's go from let's scroll until we have negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0. Okay, so we're in the right part of our table. If I fill this in, when x is negative 6, my y1 is, I'm doing this in my head because my phone just died. When x is negative 6, y1 is negative 16, y2 is negative 24. When x is negative 5, y1 is negative, y1 is negative 14. y2 is 3 times negative 6, negative 18. When y is negative 4, when x is negative 4, and you can see all this in your table, I'm just doing it quickly in my head. When x is negative 4, both of them are negative 12. When x is negative 3, y1 is negative 10, and y2 is negative 6. And then when x is negative 2, y1 is negative 8, y2 is 0. So again, what we are looking for, we want y1 to be less than y2. Where that is true, y1 is equal to y2 here. And then y1 is less than y2 above that. So we know that they are equal at -4, and then y1 is less. We have success above -4. So if we have success above -4, that's a third way of checking when x is greater than -4 or when m is greater than -4, this statement is true. So if you are confident in one of those methods, that's great. But what I would encourage you is you're in the Regents room for a long time. Once you have finished them, start thinking of what are other ways I could verify that I'm correct. Can I arrive at the same conclusion a different way? All right, moving on to 14. 14 is straight out of Unit 3. This is just like the Unit 3 quiz. A survey was taken to determine the theme for the prom. The results are summarized in the table. What percentage of the students who chose Broadway? So the important thing in this question is look for your of. That tells you what total to care about. So students who chose Broadway, in total, if we have 68 students plus 79 students, then we have a grand total of 147 students chose the Broadway theme. So the total we care about is 147 because students who chose Broadway is after the of. And then they say what percentage of them were girls. So our part is 68. We're going to do 68 divided by 147. And that will give us, I think this is 46%. Yes, that will give us 46%. Okay? So the important thing in this problem is watch out for your of. You need your of in order to figure out the correct total. If you use a different total, you're going to get a different answer. So we have Broadway girls out of Broadway students. Number 15. I'm going to pause the video here and then slice it together.